The E function is the rate at which the fish are entering the lake. The L function is the rate at which the fish are leaving the lake. That's how fast they're entering and leaving the lake. And so those are like derivative equations right there. So on letter A, it says how many fish enter in that 5 hour time span from 0 to 5 a.m., midnight to 5 a.m. Just the entering amount is just your E function. So integrate your E of t in between 0 and 5. And this one specifies nearest whole number. So do that and you get about 153 fish right there. Now letter B does not say to the nearest whole number. So you're back to doing three numbers after the decimal. But then it says what's the average number. So this is your average value formula, your 1 over b minus a times the integral from a to b from 0 to 5, just with the L function because it just says leave. So there's your entering for part A, leaving for part B. So I'm going to do my average value formula, 1/5 times the integral from 0 to 5 of the L of t, math 9, both of those. But then this one, go to three numbers after the decimal. Now, whenever you use your average value formula, the units always agree with what you're actually integrating. So L of t, it tells us both of those are measured in fish per hour. That's how fast they're entering and leaving. Those are the derivatives. And so technically when you integrate the fish per hour, you get fish, but then you're dividing it by that 5 hours again, which turns it back to the fish per hour. So it's just the average amount that's leaving the lake during that time interval. Now, letter C, the only thing weird about letter C to me is like there's not an initial amount given. It doesn't say, hey, there's like 50 fish in there at the beginning where we take into account the initial amount plus what went entered minus what left. So there is no initial amount right there. So that means I'm just going to go straight to, hey, my total amount equation. I almost always just call that A of t. That's going to be the integral of E minus the integral of L. Now, whatever, don't worry about the different letters, stuff right there, but if technically the letter that you want, always put that right there and then make these other letters different, like X's or S's or whatever there. But the goal is that you integrate it, you got X's, and then you plug in the T, you plug in the 0, and then you got your T, you got your time interval in there, right? Now, when it wants to know the greatest number in a closed interval, notice I got greatest number and closed interval underlined there. That's a 3.1 absolute extrema problem. We're about to make an XY chart, and we're automatically going to check those endpoints of the interval and then any critical numbers. Now let's review how to do the critical numbers. That's where you take the derivative and set it equal to 0. Now this is talking about the greatest number of fish in a link. So now you're taking into account how many entered, how many left. So when you integrate E, that adds up how many entered. When you subtract out the integral of L, that'll take away how many left that tank right there. So this is your total amount equation that you're trying to maximize and get that greatest number for. And so to get your critical numbers, you take the derivative. Remember, the derivative of the integral is just that inside function. So A prime is E minus L. Critical numbers is where that is equal to 0. So what I did, watch the graphing calculator video if you need a refresher on that, but I graphed E minus L as my Y1 in my graphing calculator. And then I went to my window and I made my X min 0, my X max 8, and then across the X axis one spot, and I let my calculator find that 0 for me. So watch the graphing calculator video if you need a refresher on that. But once you get that critical number, notice you gotta check the endpoints in the critical number right there. Now, what you're trying to maximize is this top blue equation here. So if I plug in 0, the integral between 0 and 0 is just 0. When I plug in 8, when I plug in the 6.204, you're plugging in the different values for t right here. And so you're going to do the integral between 0 and 8 of the E minus L, the integral between 0 and 6.204 of E minus L. Now, if that's your Y1 already in your calculator, you should be able to use that alpha trace. You should be able to hit math 9, the integral from 0 to 8, and then you should hit that alpha trace and access that Y1. That will be your E minus L equation in there. And then it's just a quicker way to do that. And then you could just go highlight it again and change the 8 to a 6.204. That's your work, that's your justification, and then that's your highest Y value. So pay attention. If it does say what's the maximum amount of fish in the lake, that's your 135.015, but it says at what time is that greatest number. So that's just your T equals 6.204 there. Now letter D. Usually when you think increasing, decreasing, I can see some of us thinking, oh, we got to take this first derivative and figure out whether that's positive or negative. But you got to be careful right there. It doesn't say is the number of fish increasing or decreasing to figure out where like the derivatives are 0. What it means is it says where is the rate of change in the number of fish increasing or decreasing. So the number of fish, that's this A equation. The total number of fish is A. And the rate of change of that number of fish, rate of change we know is a derivative, so that the rate of change of that is going to be A prime. And then they're asking us to figure out whether that rate, whether that A prime is increasing or decreasing. Now, anytime you want to know whether something is increasing or decreasing, you take its derivative and you figure out whether its derivative is positive or negative. Because remember, derivative is slope. So if its slope is positive, if its derivative is positive, that means that thing is increasing. If that slope is negative and that derivative is negative, that means that thing is going to be decreasing right there. So again, the number of fish is A, but the rate of change is A prime. They want to know, is that rate of change increasing or decreasing? So anytime you want to know whether something is increasing or decreasing, take its derivative, set it equal to 0. So if we're talking about is A prime increasing or decreasing, that means you got to take the second derivative and figure out whether that's positive or negative there. So I started right here. There's my first derivative. And I just took the second derivative. The derivative is E prime, the derivative L is L prime. And then you're supposed to do that. It says at t equals 5. So remember, the Math 8 feature in the calculator will do those derivatives for you. Now, if you already have the E minus L in your calculator as your Y1, you can do Math 8, and then for your function, hit your alpha trace. It will be that E minus L function, and then you could type in at 5, and it'll give you that right away. You could also do two different Math 8s. You could do a Math 8 with that, minus the Math 8 with that. At that t equals 5, you're going to get a negative number. And then since that derivative is negative, that means that A prime is going to be decreasing right there. So that rate of change in the number of fish is decreasing since that second derivative is negative. Peanut butter Captain Crunch.